Today we will learn about higher order derivatives. So let's start off with a polynomial function. Let's make it 2x to the fifth plus 5x to the fourth minus 3x cubed plus x squared plus 7x minus 1. Okay, we've got this nice polynomial here. And we know how to find the derivative using the power rule. And we end up with a new polynomial of fourth degree. Now we can actually repeat this process and find what we call the second derivative. And as a matter of fact, we can keep going and find a third derivative, and we can go again and find a fourth derivative, except at this point our notation changes. You can imagine that by the time maybe we want the 20th derivative, that these primes would kind of get a little annoying. So what we do is after the third derivative, we put the number of the derivative in parentheses as if it were an exponent, but it's not. So in parentheses means derivative. So our fourth derivative. And just for fun, let's find our fifth derivative. Now, just as we have different notation for the first derivative, we have different ways of expressing the second derivative. So we know we can write this as f double prime, but the second derivative of dy dx is the derivative of dy dx, and we can write this as this. So this is the notation for the second derivative, and it follows that our third derivative would be like this, and so on with our fourth derivative. Now it's not common at all, but every once in a while you may come across the second derivative written with the capital D, the third derivative, and so on. This notation on the left here is credited to the mathematician Leibniz, and on the right to Euler.